Hey everyone, can you hear me? At the back? Brilliant, okay. My name is Paul Maddox. I work in developer technologies at AWS, and this is the ECS deep dive session. So we're going to dive deep into ECS, we're going to get building things, we're going to write some code, etc., dive deep on how ECS works, some of the internals, etc. in this session. So this may not be the best session for you if you've never ever seen ECS before or used ECS, but if that's the case for you, I'll try and explain things a bit as we go through, but this is a deep dive session. So a bit about me. I joined AWS around 3.5 years ago now. I have roughly 16 years experience in the industry. I started off as a software developer many years ago. I've run ops teams and moved into systems architecture, working with distributed systems and stuff. Until very recently, I was able to say I hold all of the AWS certifications. Annoyingly, we've added another one now, the security advanced one's back out, so it's back to the drawing board for me there, and I've got to decide, do I want to do it just so I can say I've got all of them again. I'm a developer at heart. I do a lot of development in Go, Java, some C, and some Node when I can't use the other ones. My contact details are here. There's my work email address and my Twitter. Feel free to contact me if you've got any questions. I cover everything from serverless to containers to CI/CD and DevOps, etc. So feel free to contact me if you need to. So what are we going to talk about today? So rather than just dive into the individual features and functions of ECS, I'm going to try and drag it back a bit and talk about a real world use case. We're going to build an application. It's going to be made up of a couple of microservices, and we're going to analyze a Twitter stream. So this is the use case for our application. We're going to write some microservices in Go using RPC for inter-service communication. We're going to throw in some other services like Kinesis Firehose and Parameter Store, etc. as we go through. So this whole talk is going to be focused around creating this application, creating this architecture, and deploying it onto AWS in the best possible way. During this, we're going to talk about, what are the best practices for deploying Amazon ECS. We're going to talk about how to engineer for the highest possible availability. And for other optimizations, if actually you want to focus on cost rather than availability, for example, and what some of the trade-offs you can make there are. We're going to talk about scaling properties of containers on AWS and security, and also some more operational side things like monitoring and logging. So I promise this is a deep dive talk, but I need to just baseline on some terminology before we really dig in. So let's take a look at ECS. ECS is a container orchestration service, a container management service. It's an orchestration backplane that sits in AWS that looks at pool of compute, takes a container and says, where can I run this container? How can I keep this container running? How do I restart it if it dies, etc.? So there's a couple of key parts here. First of all, in the middle, this kind of spaceship in the middle, you've got the actual Elastic Container Service here, ECS itself. This is a managed service in AWS. It's not something you have to carry the pager for, and it's completely free as well. So with ECS, the only thing you pay for are the actual container instances down the bottom here that run your containers. And these are just EC2 instances. Running Windows, running Linux, maybe GPU enabled, maybe not. You have an extreme amount of flexibility here because they're just EC2 images running our open source ECS agent, connecting them into the cluster. There's a couple of ancillary things here at the top right. So we have a container registry. This is a really nice option for building your Docker containers and pushing them somewhere and storing those artifacts so that they can be deployed. You can deploy a container registry with a couple of clicks. You can integrate it with IAM permission. It has encryption at rest, etc. Really nice, secure way of storing your containers. The key unit of deployment with ECS is a task definition. If you've used Kubernetes before, this is similar to the concept of a pod. It's a JSON-based document that contains your containers for your deployment. And volumes as well. So it may be that I have a small application that needs 2 containers. It's got like a back-end logic container and then maybe a caching container. And I always want to deploy them at the same time together. So I wrap them up in a task definition, give the task definition to ECS, and ECS is going to work out where in my cluster that can be scheduled, and it's going to maintain and monitor it and keep it running and do things like load balancing and service discovery, and we're going to cover a lot of that as we go through. So one thing that was announced at reInvent that kind of changes this a bit is Fargate. So a lot of people ask me, how does Fargate fit into this sort of diagram that you have? So Fargate is a deployment option in an ECS cluster. When you create an ECS cluster, when you deploy a task definition to it, you can just choose deploy this task to EC2 or deploy it to Fargate, all within the same cluster. And actually with Fargate, the cluster is your logical boundary for isolation. So behind the scenes, if you deploy a container, either on Fargate or on EC2, and you deploy it to an ECS cluster, we're not going to run it on the same infrastructure behind the scenes as other clusters containers. So it's an isolation boundary. So I'm going to walk you through each of these areas and just talk about the division of responsibility. At AWS, we talk a lot about the model of shared responsibility. And typically in AWS, if you look at EC2 and running VMs on EC2, for example, we talk about AWS being responsible for the cloud, right? The security, the operations, etc., of the back-end services like EC2. So we're going to carry the pager for that. We're going to worry about the availability of EC2, whereas the applications that you might be running inside your VMs and your own architectures within AWS is your responsibility. So you're responsible for security and operations, etc., in the cloud, using the building blocks that we provide. So I'm going to run through the different components of ECS and just sort of clarify where that division of operation sits. So with ECS itself, the backplane service that's actually scheduling all of the containers onto your clusters, we're going to be looking after the security of it. So AWS is responsible for the security, the compliance story, like PCI, SOC 1, 2, and 3, ISO 27001 compliance, etc. That's our responsibility to get all of that certified. You just reap the benefits of that. We're going to be monitoring it and paging people if something goes wrong, and our engineers are going to be looking after that, patching it, availability, scaling, cost control. These are all concerns that AWS is responsible for, as it's a managed service. You just need to deploy an ECS cluster. So with ECS, you can do this with just one command, right? CloudFormation, APIs, CLIs, etc. And you can deploy your first cluster with just one command. It's not going to have any hosts in it, but you can still actually deploy a container with Fargate. But typically with ECS, if you're running on EC2, you'd want to deploy some instances at this point. So with our container registry, similar story. We're going to be looking after the monitoring and availability of the container registry. We're going to be dealing with scaling it out, storage, etc. You're not going to have to worry about that. You should just push your container images, and we'll store them for you. But you're going to have to orchestrate pushing those container images, right? We're not going to do that for you. Things like cost control. So if you're pushing a lot of containers as part of an automated CI/CD job, for example, you may end up with a lot of containers within the registry. Luckily, the registry has some nice options for you. You can set up lifecycle policies and say, hey, if an image is untagged, for example, delete it after 30 days. And there's building blocks there, but it's up to you to configure that. Then we get to the actual container instances. These are the EC2 instances that actually run your containers and that the container engine is scheduling the containers onto. And in this case, these are your responsibility. EC2 instances. You're thinking about cost control and running on spot and reserved instances and stuff, and thinking about the security, like the security groups and stuff that may wrap those instances. So there's a bit more on the responsibility side for you. So a lot of this talk today, we're going to be talking through what's the best practice here, how to deploy them, what does it look like, what does good look like. Luckily, there's a whole load of standard building blocks to help you with this, right? And I don't want this to be a slide that's just mentioned tons and tons of services. You don't have to worry too much about these as we go through. This can be a nice reference slide you can go back to afterwards. But there's a whole load of building blocks to help you here. So when you're deploying EC2 instances on AWS, you can use something like Amazon Inspector and run automated vulnerability tests to check for CVE vulnerabilities in packages and stuff. With EC2, you get auto-scaling to scale in and out your pool of compute. You get CloudWatch metrics built in. So while these things on the left are your responsibility, there's a whole load of tooling to help you here. The other thing is tasks and containers themselves. When it comes to the actual task definitions, we're going to be actually working out where on your cluster that task definition can run and deploying it, etc. But you are going to have to put some thought into how you want your tasks and your containers to scale in and out. Do you want them to auto-scale? And we're going to cover all this in more detail as we go through. So how do I deploy this, right? This ECS cluster, all my container instances, etc. What's the best practices? Who here's using ECS today? Okay, shout out. How do you deploy this today? Someone else does it. It's the ops team. They do it. So, okay. I'm going to talk through some of the options. The first one, depending on where you are with your journey with ECS, maybe the AWS Management Console, right? The web interface. It has a wizard that's going to help you spin up a cluster in no time at all. This is a good option to learn about the service. If you're an organization that's a bit more advanced in your AWS ECS journey, you may want more flexibility, more control, right? You may want something more repeatable. So if I need to create like 10 different testing environments, the last thing I want to do is create them all manually with the console, right? There's loads of opportunity for human error there. There's no repeatability. It's hard to test, etc. So the next natural thought for a lot of people is, hey, I'm going to flex my scripting skills. I'm the king of the bash one-liners. I'm going to write a bash one-liner that deploys everything, and it's going to be amazing, except it's probably not going to be amazing. Because this is quite a hard prospect. Okay, I don't know if you can read that there. It's quite bright in here, but I put together a tiny little script, and already, like deploying a cluster, I've got things I need to think about. So what happens if halfway through my script fails? Am I going to have to write error checking all the way through my deployment script? Some actions in AWS are asynchronous. So creating an EC2 instance, for example, with the run instances command is asynchronous. When I run the command on the command line, it's going to return straight away. That doesn't mean my instance is there yet. It's still provisioning in the background. So what do I do in my script? Do I pause? Do I do like sleep 500 seconds? How long should I sleep for? It gets a bit confusing. And then how do I roll? Yeah. It's going to be quite tight for time, this talk, I think. So I'm going to do questions at the end for this one, if that's okay. The next one is, how do I upgrade? How do I roll back? You know, this approach, while it seems simple at first, generally leads to, you know, a lot of technical debt to maintain. And when you think about what deployment should actually look like, generally you want something self-contained, deployable unit that's repeatable, something that you can cookie cutter over and over again, something that's auditable, ideally something that's self-documenting. So if you're the type of organization that's got a wiki page somewhere that lists, you know, subnets and IP ranges and stuff, you typically probably realize that that gets out of date very, very quickly. Really, you want to be deploying your infrastructure in a way where you've got infrastructure as code, and that definition of your infrastructure is always up to date and contains a self-documenting version of your architecture. And this is where CloudFormation comes in. So CloudFormation allows you to describe any AWS resource via a template, a JSON or YAML template, and you can actually commit this into version control with your application. So at any point in time, I can look at my application in GitHub or wherever you store it and say, okay, this version of my application had this architecture. And on this date, Steve introduced a firewall rule, and the next day everything broke, so I need to go and speak to Steve but not hit him because we're a blameless culture, etc., etc. So time to deploy. We've got our CloudFormation template. You can use the create stack command or the web interface or integration with like Jenkins or code pipeline, etc. to deploy. And you can create a stack and just give it this template name, and it's going to go away and deploy it. When it comes to updating your stack, you have a similar update stack command. You can update all of your resources. When a new environment is required, you can just give it a different name. CloudFormation is going to bring out another copy of your infrastructure. So really, really nice way to just cookie cutter your infrastructure. When it comes to some of the ECS resources, I'll give a few examples here. We've got an ECR repository, so somewhere to put your container images. This is really easy to deploy with CloudFormation, just an example there. Top tip if you're using ECR today, ECR is integrated with IAM. So you can use AWS IAM to protect your registries and say, okay, you know, this person can upload a container to this repo, but not to that one. Or this application can pull a container from this repo, but not from that one. So typically there's a command you run, AWS ECR get login, that's going to do the Docker login for you. There's an open source plugin on our AWS Labs repo for Docker that just automates that process so you never have to log into ECR. So really, really easy option there. Just a little tip as we go through. ECS clusters, again, very similar, very, very easy to deploy with CloudFormation. Container instances. And this is where it gets a little bit more interesting, complex, depending on how you want to look at it. On the left here is an architecture for a very typical ECS deployment. okay, for the container instances that live in your AWS account. And don't worry if you can't read this at the back. I'm going to walk through this and explain it as we're going through. Ultimately, we've got 2 availability zones here. So you may have 2, you may have 3, etc., but multiple availability zones. Each availability zone is 1 or more data center, separated by low latency, normally under 2 milliseconds. So what this means is our architecture, if it spans multiple availability zones, is going to be highly available. If we have some container instances die in one, they're going to be brought back up automatically in another one. So in this case, let's look at the route for inbound traffic to our containers. So we've got our VPC that spans the regions. We've got an internet gateway at the top, and then we've got an application load balancer. So the ALB, or application load balancer, is a really, really nice way of routing traffic into your containers. So you probably don't want your container instances in a public subnet with public IPs and all your containers getting public IPs, etc. You probably want a sort of tiered architecture whereby you have a load balancer in the public subnets and then your container instances in the private ones. The application load balancer allows you to do path-based routing or host-based routing. So I could take, for example, /products on my API RESTful API URL and send everything that goes to /products to all of my product microservice containers. And it can do that routing for you with a single application load balancer. Okay. Outbound traffic. At some point, your container instances or your containers may want to access the outside world. And this could be because your containers need to talk to a third-party API, for example, maybe like a payments API or something, or maybe some sort of monitoring system, etc. So the usual way to do this in a VPC that has public and private subnets is to use NAT gateways. So in this case, we've got some NAT gateways that are taking the traffic and sending it out to the internet. Logging. ECS has really tight integrations with CloudWatch logs. So you can actually set up centralized logging for all of your containers and all of your container instances really, really easily. It's going to collect all the standard out and standard error from all of your containers. It's going to centralize it in CloudWatch logs, and there's a load of fun stuff you can do with it there that we're going to cover as we go on here. And the too long, couldn't be bothered to listen to, you didn't read your slides version of this, is that everything I've just shown you can be automatically deployed to your AWS account with a click of a button. So we have a reference architecture published on GitHub, and it's basically that whole architecture I just showed you. So I'm going to just skip out here and go and build. Here we go. Okay, so this is the reference architecture. It's just in the AWS Labs GitHub. If we look down, we can see there's a launch stack button for all of our regions. It just describes what it's going to deploy, etc., and some common frequently asked questions. So if we look in the CloudFormation templates here, we've got infrastructure, so there's templates for like setting up the cluster, there's templates for setting up a VPC. You can fork this and go and tweak it and tune it to your own VPC definitions, etc., IP ranges. I'm just going to deploy the default one, and I'm going to deploy it into, I don't know, London region. Okay, so this takes us to the CloudFormation console. It's pre-populated the template location for us. I can go through, give it a name. I'm going to call this cluster pre-production. And just skip through some of these options. Okay. So what's going to happen now is over the course of the next 6 to 8 minutes, that whole architecture I showed you in that diagram is going to be brought up. Okay, so we're going to have a cluster up and running with container instances, the NAT gateways, all set up following best practices. So I'm not going to sit here and wait for that for 10 minutes. I'm actually going to go back, but that will be deploying in the background. We'll look back at that later. Did you want to do your question quickly? It's kind of a good segue point.
Just the bash skills that you need.
Yes.
You need them even if you're using CloudFormation, in my experience. There are like Jenkins plugins to help you out with this.
Good question. So,
other alternatives.
Yeah. So the question was, even if I'm using CloudFormation, do I still need to use Bash, etc.? What if I'm using Jenkins or some other CI/CD like type orchestration system? Yeah, there's plugins for Jenkins for CloudFormation, so you can just deploy a CloudFormation template straight from Jenkins. Things like Code Pipeline have native support built in, so you shouldn't need to. But if you want the power, you can break out and use that. But you shouldn't be creating resources manually with the command line, was kind of the point there. You can use the command line to deploy the CloudFormation template.
Yeah, that's what I do, but I still have a lot of Bash scripting, even if I
Okay.
stacks,
Okay.
in my experience.
Okay. Come find me over lunch and we can talk that through and see if we can optimize that.
Nice.
Okay. So we got a cluster deploying, right? In a few minutes' time, it's going to be ready for us to start using. Let's actually get to the more interesting bit and start talking about building applications. So we're going to build an application that looks something like this. And caveat, I built this over the weekend. It may not be the most polished thing ever. So this is going to be a little two microservice architecture. It's going to pull tweets into a service I've created called the Tweet Collector. So this is going to interface with the Twitter API. It's going to subscribe to a Twitter search and pull in all the tweets that match that Twitter search. Now the Tweet Collector needs API credentials to talk to Twitter's API. Right, so my Twitter token, etc. I didn't want them to be shown on stage to you. I didn't want them to be recorded, and I want them to be kept securely. So a nice option here is the AWS parameter store. If you haven't seen this, this is a pretty hidden away service in the EC2 console, and it's basically a put object, or it's a key value store with put item and get item type API. But it has encryption built in. So it can encrypt your parameters automatically with our key management service. So you get a really nice, secure, IAM-controlled way of storing configuration and secrets. So really powerful here. I'm just going to use it to store my Twitter credentials, and the microservice is going to pull that. And then it's going to send on any tweets it finds into this next microservice called the archiver. And this is going to do a few things. It's going to send the tweets onto Kinesis Firehose. Kinesis Firehose allows me to archive things into S3. So Kinesis Firehose is going to batch up all those tweets into 5 or 10 meg blocks, whatever I decide. It's going to do things like gzip them, etc. So I've got a nice archive sitting in S3 of all the tweets over time, right? It's also going to allow me to send on those tweets to something like Elasticsearch, so I can do analysis and graphs, etc. of the tweets. And it also gives me the option to send it on to Lambda if I want, so I can do like real-time notifications and stuff. So this is our general architecture here. Did anyone see this announced about a week ago? No? Cool. This is really interesting. So I'd originally built a load of this already and ended up rewriting it at the weekend because I found this new library that Twitch have released. And it's a really interesting library for microservice communication. So typically when you're building and publishing microservices, a very common option is to write RESTful APIs for them. Use something like Swagger maybe to define your RESTful APIs and build clients, etc. You can get into the scenario where all of your microservices within your organization have a different way of using REST. Like REST isn't specific enough at times. So you end up with like different RESTful endpoint names like maybe create or etc. There can be key differences there. And for me, writing Swagger definitions always felt quite painful. Right? It's quite verbose, etc. Personal preference there, but I found that quite painful. This is actually something that Twitch use heavily internally for their microservice communication. It works with protobuf definition. So I define my models for my API with a protobuf definition, and then this is going to generate me a server. This is going to generate me a client. It's going to deal with the underlying RPC communication for me. Interestingly, so one of the other ways of doing this would be with gRPC. So gRPC is another library very similar to this, but it has some limitations. Number one, gRPC only works with protobufs, to my knowledge anyway. So that makes it hard if you want to diagnose a service with curl or something from the command line, because if protobufs is a binary protocol, it can be quite hard to work that way. So this allows you to use JSON as well. It's also HTTP1 compatible, whereas gRPC is tied to HTTP2. So it means you can't use it with any of the AWS load balancers, for example. So this is a really nice option for AWS microservices communicating together. So we're going to use this in our application. On the left here, can you see that at the back? It's really bright in here. It's not, okay. So on the left here, I've got a protobuf definition that basically says, okay, I'm creating a new service called Twitter Archive. I want a method called create. It's going to take a create request and respond with a create response. And then I define what my models look like. So a create request to the Twitter archiver has got a name and a message. So the person tweeting and the actual tweet. And then the response is going to return with the Kinesis sequence and shard number. So let's look a tiny bit deeper at the two services here. We've got a Twitter collector microservice that I've already written. Because I want to containerize this microservice, I need to be able to provide a way to configure it at runtime. This is fairly key with containers. Ideally, I want to build my container once at the beginning of my CI/CD pipeline and use that same container in any different environment, dev, staging, prod, etc. I don't want to have to rebuild my container for each different environment because the configuration data is different. So the common 12-factor app way of doing this would be to use environment variables and pass in environment variables to configure the service at runtime. So here, this service takes two environment variables, one that specifies the search terms to subscribe to in the Twitter API. The other one is the URL of the archive service that's running. It's going to need an IAM role, so it can fetch my Twitter credentials from the parameter store. And then it's going to use a client SDK generated by that Twitch library to allow it to communicate with my other service. On the other end, the archiver, again, written in Go. This actually hosts the auto-generated RPC server by the Twitch library. And it's going to receive tweets, validate them, and then send them onto a Kinesis stream. So I've got an environment variable to configure it at runtime, so I can specify which Kinesis stream it should send to. It's going to need an IAM role to write to the Kinesis stream, and it's going to respond with a response. So what does my development workflow look like for this? This is the way I typically develop with ECS. So I normally use Docker Compose locally. Docker Compose is released by Docker, but it allows you to specify a load of containers and bring them all up locally and play and build and test and push your containers. So a really convenient way of running containers locally. All the logs are just thrown to standard out, standard error in my terminal. It's going to use my local AWS credentials, and I'm going to use this to build and push containers. And then when it comes to deploying into AWS, I'm going to use CloudFormation. I'm already using CloudFormation to deploy my cluster. You can just specify your task definitions in CloudFormation as well. I want my logs centralized in CloudTrail. I want to use task roles, and we're going to cover those in a bit more detail as we go through, to assign permissions directly to the container. And then I want centralized logging and metrics in CloudWatch. So this whole project is open source on GitHub. You can actually go to my GitHub and look for a project called RPC Demo, and all the sources is on there. So again, we're going to share the slides at the end. You can get them there. But we're going to talk through running it locally, and we're going to deploy it into AWS. Okay, so we've got our two services here. I'm going to show you the archiver service first. So this is the service that hosts a server and receives tweets from the tweet collector. So in this case, I've got my protobuf definition. And then using the Twitch library, I can just run cd archiver, go generate. And it's going to generate me my server and client for me automatically. So really quick way of doing the coding there. And then here I've got my actual main application where I'm just instantiating. Can we shut the blinds anymore at the back? Does anyone know? It's very bright in here.
Maybe you can pull the curtains.
That is a good idea. Yeah, I don't think that's such a good idea after all. Nice try. Okay. So I've got my tweet collector service, the archiver service. This is just going to send stuff on. And then I've got here my collector service. And this service just subscribes to a Twitter API and subscribes to a search stream. So here I'm basically fetching my authentication tokens from SSM. And then I'm setting up my search terms based on the environment variable set, subscribing to the Twitter stream, and then instantiating a new client for my other microservice. And this is going to automate all the RPC communication. It means I don't have to deal with HTTP or REST or worry about transport mechanisms at all. This does it for me. Okay, so to run this locally, if I just open up a terminal, I've got a Docker Compose file. So this Docker Compose file has a couple of things. It's got both of my containers here defined. So the top one, I've got my collector, and I'm saying, okay, the build, when I run Docker Compose build, look inside the collector directory and run the Docker file that's in there to build my container. And then when I run push it to this image, and there's an ECR registry repo I've already created there. This service depends on the archiver and pass in some environment variables. So in this case, I'm searching on Twitter for anything mentioning Amazon. Because I'm going to show this on screen, this was actually really hard to find a Twitter term that was work safe to show on screen. Really hard. You've got to trade off between you want one that's popular and is going to have loads of tweet streaming by, but something that's fairly safe as well. So this could be a risk that sees me not having a job at the end of this demo. So we've got our search, we've got our collector is going to be collecting tweets, and then we've got the archiver service, and this one we're exposing on some ports, and just this one connects to the other one just using the name of its container. Right, so I can run Docker Compose up, Docker Compose up. So it's just going to bring up my two containers. It's going to subscribe to the tweet stream for Amazon. And the messages you're seeing there are actually from the archiver service that's received them and successfully sent them on to Kinesis Firehose. And I'm going to close that before it says something horrific. Okay, so we got our two microservices. We're developing them, we're building them, we're running them locally. At some point, I'm going to want to send these into AWS and run these containers in a more durable, available way. So to do this, I've got a CloudFormation template within my repo. And this CloudFormation template, I just copied from that reference architecture, by the way. The ECS reference architecture I showed you comes with a load of example microservices built in. So I just copied the CloudFormation template and replaced the details with some of mine. So here I've got, for example, the search terms and a couple of parameters at the top. And then very similar to the Docker Compose definition, I've got my two containers specified here. So here we're just telling ECS, pull this container image, limit it to this much memory, use environment variables to set all of the different parameters for like where to access the other service and what search term to search for. So then I can take this CloudFormation template and do AWS CloudFormation create stack. Give it a stack name, so in this case I'm calling it production tweets, and then the template body file, so the actual CloudFormation template that I've got on my file system. So this is now going to go away. It's going to send that template into CloudFormation. If I go into my AWS console now and look in the right region. Okay, I can see my CloudFormation stack's been created. I've already got a cluster I created there earlier, the production cluster, and then I've got my production tweets microservices that are being deployed now. So I can actually go into CloudFormation. I can see, okay, there's a whole load of resources that it's going to create for me. So like a log group for centralized logging, my Kinesis stream that all my tweets are going to end up in. It's going to start deploying the ECS services, etc. in a minute. And this typically takes about a minute or so to deploy. You can see it's already started deploying the ECS service there. And if I go into the ECS console, okay, so I've got my cluster here. And I can go in, I can see I've got a load of services running. So the top two there are the example ones that come with the reference architecture. And then I've got my service at the bottom, and you can see at the moment it's currently deploying the container. So I can see here I've got one task pending. So right now it's pulling the container image from my registry. In my case, the container is about 500 meg because I haven't optimized it at all. I'm just using the default Go container. So there's about 500 meg for it to pull. It should take a minute or so. There we go, and it's running now. So now my service is up and running. I can go in, I can look at that task that's running. I can see I've got my two containers there up and running successfully. And I can actually start going and looking at the logs now. So part of that is task definition. If I look back at the CloudFormation template here, I've got my archiver service here. To add centralized logging in here was a couple of lines. I just specify a log driver for this container. And there's a load out there, so you can use things like Splunk or FluentD, etc. There's one within the Docker GitHub repo called AWS Logs, and this is just going to take all the logs and send them into CloudWatch logs automatically. And I just give it a prefix of where I want it to store, so I can organize and sort them properly. So now if I go and look in CloudWatch, and look at logs. Okay, so I've got a log group that's been created for my service logs. And I can see here, okay, I've got some containers running. I can go and look at the archiver, for example, and see, okay, there's a whole load of tweets being archived, just like I showed you on my local laptop. So my service is up and running. I can go back into ECS. I can look at metrics and CPU and memory and latency, etc. for it. All of that is graphed for you out of the box. I'm going to show you one other cool thing you can do here as well. If I go back to my log groups, production tweets, there's some functionality within CloudWatch logs called metric filters. Has anyone seen or used metric filters before? Yeah, not many people have seen this. This is a really cool feature. I can click on a log group in CloudWatch logs and create a metric filter. This allows me to specify a search pattern. So I may want to search and look for anything in my logs that contains the word warning. Okay, I can test it now. There's no matches at the moment, but if any of my containers did output a message in the logs that said warning, this creates a CloudWatch metric out of it. So I can say warnings. I can then do things like set alarms on that. So straight away, I've got alerts and alarms that can trigger Lambda functions or integrate with existing monitoring systems for any search time in my container logs. Really, really quick, really, really powerful. These automatically get graphed as well. So any metric filter I create, I can just go into CloudWatch and I can see a graph of all my warnings and see when they happened. And I can actually right-click on the graph and the point in the graph and show me the log entries for this particular point in the graph. And it's going to show you a cut-down version of the log entries. So you don't need to go trawling through log entries when everything goes wrong and you're trying to diagnose stuff. Very quick way to get to container logs. So this allows me to do things like set up graphs very easily. I've got here for my service. You can see I was testing it yesterday in the hotel room and then deleted it, recreated it just now. So we can see we've got a whole load of tweets being archived. We can see processing errors, etc. That's one of the metric filters there. So really, really easy with the integration with CloudWatch metrics. Okay. Let's just check. Okay, so at the moment, our microservice, the archiver, is sending all of the tweets just into Kinesis. At the moment, there's no S3 archiving going on. So I'm just going to show you how you'd implement that with Kinesis. Okay, so within Kinesis, Kinesis has the concept of a data stream. This is the collector that collects all the messages sent into it. And then you need to choose what you want to do with that data stream. So the archiving to S3, for example, or run SQL queries across it. I'm going to create a new delivery stream here in Kinesis. I'm going to say tweets to S3. I'm going to connect this delivery stream up to my production tweets Kinesis stream. It gives me a chance to transform records. So for each individual record that goes through this delivery stream, I can use a Lambda function to actually modify the record as it goes through and do transformations. In this case, I'm not going to. I'm going to choose my destination. So S3 in this case, but I could just easily send these search results into Splunk or into Elasticsearch. And I'm going to choose a bucket here, pMaddox tweets. I get to choose how much I want to buffer these tweets that I want archived. So I can split them up into 5 meg increments. So Kinesis is going to take those tweets, it's going to zip them up into 5 meg bundles. I can do things like enable gzip compression on the fly to save me some money in S3. Let's create an IAM role that allows that. Okay. Okay, and with a couple of clicks, I've taken those tweets coming into Kinesis, and I'm now going to automatically get an archive in S3. So if later on I decide I want to, create a machine learning model or something and use this data to train it, I've got an archive of all that data. So I can now go into S3 and look at my tweets bucket, and I'll see a whole load of stuff in there. So here we go. For example, there's some tweets that have been gzipped up. So in this case, I've got my tweet collector collecting the tweets. I've got my archiver send them on to Kinesis, and Kinesis archiving off to S3 and optionally allowing me to send them other places too. Cool. Any questions so far? No? Yes? Yes, that's a really good question. So the question was, hey, Paul, you just showed me a load of manual stuff after telling me not to do manual stuff, basically, to paraphrase. Everything I showed you there manually was just kind of visually to get the point across. Everything I showed you can, and in reality, in a production environment, probably should be done with CloudFormation. So yeah, that would be the preferred way. I just wanted to highlight some of those features as we went through. I think it's also important to say as well, I've gone with the more advanced method of using CloudFormation to deploy all of this. If you wanted to just get started with ECS and deploy your first containers, you can use the management console as well. There's a wizard that will guide you through that process. Okay, so next steps here. If I wanted to take this further, we recently released a blog post reference architecture that basically takes this Twitter analysis concept a bit further, using machine learning, using things like QuickSight for graphing. You can actually deploy this whole architecture with a click from this blog post. And this blog post is quite an interesting read, using machine learning against tweets to try and predict certain environments and conditions. Okay, so we got an application, a really quick, basic, rudimentary application. What else do we need for production with ECS? Cost optimization. At some point, when you first move to containers, if you're an organization that uses EC2 today, for example, and deploys your applications, 1 or 2 or 3 EC2 instances per application, containers are probably a really attractive proposition. They allow you to bin pack bound better, get better usage of your containers, your instances, so you'll probably save some money by moving to containers in terms of raw EC2 costs. And you'll run like that and you'll run like that, but at some point you may want to save more money. So with ECS, you're free to use the normal EC2 pricing models. So reserved instances, this is a really common one. You can reserve an instance if you know, for example, I've got a baseline capacity requirement in my cluster of like 10 instances. Sometimes I peak above that, sometimes not, but generally I have about 10 instances worth of workload. You can actually reserve those instances and commit to like a 1 or 3 year commit, and in return AWS is going to give you a price reduction on those instances. So that's a really common option. Use reserved instances to reserve your baseline capacity requirements and just burst into on-demand pricing as you need to. The next one is spot instances. So ECS fully supports spot instances. If you haven't seen spot before, it's a really, really good way of saving money on AWS. So it allows you to bid for unused capacity in our data centers, and you get a really, really good cost saving on doing this, so up to 90% on some instances. So really good cost saving. The caveat is, at any point, we could take those instances away from you with 2 minutes warning. Okay? So typically when you use spot, traditionally you always bid it on, okay, I want an M4 large and I want it in this particular availability zone. And if we suddenly had a run on M4 larges in that availability zone and the price went up above what you bidded, you'd lose that instance. And it's not great for production when that happens, obviously. So you can actually use spot fleet within ECS really easily. And it allows you to say, you know what, I don't really care what instance type I use. Doesn't really matter to me. I've got this big pool of compute. What I really care about is I want this much CPU or this much memory across these AZs. Right? Spot, go away, work it out. And by using spot fleet, you're actually diversifying your bidding strategy with spot there. So you're much, much less likely to get those instances taken away from you. That said, it's a risk cost-saving conversation for every company. I know financial institutions that run Spot for production workloads and they feel confident with it. I know some companies that just want to run dev test on Spot. Even if you're just running dev test on Spot, you can probably save a lot of money. So I encourage looking into that. Another thing with ECS is to make use of multiple ECS clusters. To deploy an ECS cluster is easy, it's quick. So actually having multiple ECS clusters is pretty normal. They make a really good boundary for isolation for dev versus prod, for example, so that your dev and prod containers are running on different infrastructure behind the scenes, and like a kernel exploit, for example, isn't going to allow a dev container to break out into a production container. So using separate EC2 instances under the hood for that isolation by using separate clusters is really powerful. It also means you can use different pricing strategies for different containers. So you may say dev Spot's fine. In production, we want to use that auto-scaling group strategy with reserved instances I mentioned. Or maybe you want to have a cluster for all of your PCI certified workloads so that when you go through a PCI audit, the scope of the PCI audit is just the stuff running in that cluster. Like, these are all common use cases for creating separate clusters. Scaling. How does scaling work with ECS? So there's two dimensions to scaling on ECS. The first one is your container instances, the EC2 instances that actually run your containers. Because they're just EC2 instances, you can use normal EC2 primitives like auto-scaling. So you can say, I want an auto-scaling group that spans all the availability zones, and I want it to scale up and down automatically as needed, so I have this nice fluid pool of compute. A good recommendation for what to use as that scaling metric is the memory reservation metric in CloudWatch. So when you deploy a container, typically you'd reserve amount of memory for that container, so you know as you deploy more and more containers, you need to scale up based on that. So that's a good one. I'm going to show you some more resources for some more advanced strategies here right at the end of the presentation though. So I can scale up and down my pool of compute automatically. I could do that via this. I could even do it via a custom metric if I wanted, like some field in a database or something. And then there's actually scaling of your containers. So you scale in and out your pool of compute, but then maybe I'm running an Nginx container, and I know each Nginx container can handle 30,000 transactions a second, for example. So I want to scale in and out the number of containers I'm running. So you can do a very, very similar thing, but with your actual containers and tasks, and scale out how many of your tasks and containers are running at any point in time, scale them out and scale them back in automatically. And in terms of the metric to use for these, it really depends on each application. There's no hard and fast rule for what's the best practice here, but you can choose metrics such as CPU or memory or custom metrics like number of transactions a second. Okay, security. What should I do about security with ECS? What do I need to think about here? One of the questions that comes up quite often is, okay, I've got my pool of compute up and running, my EC2 instances. How do I update them and how do I patch them? And this is actually pretty easy if you're using CloudFormation. So AWS publish an optimized AMI, the operating system base image, specifically for ECS. It comes with the ECS agent and Docker all pre-installed and configured with some optimizations. And we publish an SNS topic every time we make a change or an update to that AMI. So you can hook into that automated feed and always know which is the latest AMI. Then in your CloudFormation template, in that reference architecture I showed you, or your CloudFormation templates, you can just replace the AMI ID with a new one. CloudFormation behind the scenes is going to use something called an auto-scaling rolling update policy. So within that reference architecture I showed you, there's already one defined, and it basically says do a staged rollout of this change that's just been made. Don't go and take down all my container instances all at once. Do one at a time or two at a time or whatever that batch size that you choose should be. And it gives you flexibility and an automated way of doing these zero downtime deployments just by changing that AMI ID. The other side of patching is containers. So actually patching what's inside your containers. And this is something I don't hear customers talking about enough or asking about, is actually the security of what goes on inside your containers. There's a couple of nice solutions in the market, like Aqua Security have one, Twistlock is another one I'm showing here. And this basically slots into your CI/CD pipeline, and whenever a Docker file is committed into version control, this is going to go away and build it, and it's going to make sure that none of the packages or dependencies within that container have any vulnerabilities or CVEs, etc. It's then able just to reject it straight away and never put that container into production if it doesn't pass your security requirements. So a really easy way to drop container scanning into your CI/CD pipeline. So Twistlock, these guys, Aqua is the other main one I hear about here. Another top tip is to try and keep your containers as small as possible. So in my example, my containers for those Go microservices I wrote were like 600 meg, because I just used the default Go base container, which compiles it and has the whole runtime and basically half of Linux built into that container. So actually what I should have done and could have done is to start from a small base for my container. So within Docker, you have the scratch image, which is basically an empty image, nothing inside it at all. And because Go compiles static binaries, I can just add in my binary, and that's enough. It doesn't need a full operating system and all the security risk and patching requirements that come with that. So wherever possible, keep your containers as small as possible and keep that surface area down to minimize your risk. Another security front here is IAM Roles. So EC2 has had the concept of IAM Roles for a long time. They allow you to assign to your EC2 instances permissions in AWS. So I can have an EC2 instance that is allowed to access S3, for example. You can do that at the host level with ECS. That just means every container on that host is going to get those same permissions. It's not very granular. You may want to do that at times because every container talks to a specific monitoring system or something, but it's pretty rare. Generally, what people want to use most of the time is IAM roles scoped down to an individual container or task. So ECS allows you to do that. When you launch a task, you can just say, hey, give it this AWS IAM role. And it's going to get all those permissions, and it's going to be very granular and scoped down here. Monitoring and logging. I showed you the monitoring and logging quickly that was included. Out of the box with ECS, you get monitoring with CloudWatch, so I can go and see at a cluster level or an individual service level, my CPU, my memory metrics and reservations, etc. I can actually go a bit deeper and look at things like latencies on my load balancers and how many 500 errors I'm getting. And all this is there out of the box for you. If you don't want to use CloudWatch, there's an open source Prometheus exporter for ECS. So if you're running Prometheus internally today as an alternative solution for monitoring, you can just have ECS report all of its metrics directly into Prometheus. Centralized logging, I showed you. There's a couple of other options there for the different plugins. So if you're running Splunk and don't want to use CloudWatch logs, for example, you don't have to. So load of different options for centralized logging. We saw the centralized logging console earlier. Metric filters, really cool feature. If you're using CloudWatch logs, I recommend looking into metric filters. I want to wrap up with a slide. If you take one thing away from this whole talk, take this away. This is a repository on GitHub published by one of our developer advocates, Nathan Peck. So he's an ECS developer advocate, and he's basically spent the last year or two collecting, aggregating every bit of cool information, every cool open source project, etc., related to containers and related to ECS. So if I just open this up here. Awesome ECS. Okay, so this GitHub repository's got a whole load of sections, right from things like, okay, if I want to do self-hosting in EC2 or want to use Fargate, if I want to use infrastructure as code. We spoke today about CloudFormation, but hey, what if we're a Terraform shop? So there's links to the equivalent in Terraform. Deployment tools that people have created, things like Empire or Cold Brew. So these offer like a higher level abstraction on top of ECS. So nice, easy command line tooling to use. Load of implementation guides on like what's the best practices for scaling, etc. How to use things like Linkerd and Weaveworks and how to do data persistence. There's a whole load of resources here and recommend going and checking this out. I'll leave that GitHub repo at the top there. And that's it from me. I think we've got 10 minutes or so for questions if people want. Yes, sir.
.NET developer, you got Windows. How does it go with Docker and ECS in general?
It goes well. So around reInvent time, so November time, we launched Windows. It's been in preview for a while, Windows containers with ECS. It's now generally available and ready for production use. So you can spin up clusters that have Windows hosts in them, and you can deploy your Windows containers to Windows hosts. If you're using .NET Core, you could just deploy them as normal on Linux anyway, but you have the option now to run Windows containers. There's a really good talk on YouTube done by one of the engineers on the ECS team at reInvent on Windows containers, etc. There's got a load more detail there. So I recommend that. Yes, sir.
So you mentioned ECR credential. When will you start the version and ship compile binaries?
So ECR, the container registry, the question was, when are we going to start to version it and ship compiled binaries? I'm not sure I understand what you mean about unversioning there. Like when you push a container image. So ECR, the container registry that you push. So I build a doc. Sorry? The credential helper isn't versioned. Okay, that's really good feedback. Let me go back and take that back to the team because, yeah, that should have a deployment and update and release strategy if there isn't one today. Thank you. Yes?
About security, and also in my team we are like, how much security should we strive to maintain within our VPC? So for example, TLS terminates at the load balancer, it's unencrypted traffic between the load balancer and container.
Yep.
Best practice there.
Okay.
Currently we're doing termination of new TLS connection between them, but we are not certain we should keep that.
Okay, so the question was around security between containers, so container to container security and load balancing, etc. So let me talk through the two options there that you have. The first option you have is the VPC constructs itself are PCI certified. Right? You can take PCI workloads, you can run them in VPC, and we certify the security of VPCs to that level, a load of other different security compliance credentials as well. So you can be safe that when you're deploying into VPC, the communication within a VPC is secure and is safe. Now, it may be that you want to go one step further, and you want to have, okay, within my VPC, how do I stop a bad actor, listening, if they get onto a host, etc., how do I stop that? Maybe I have a corporate requirement for encrypted traffic even within the VPC. You can totally do that. I worked with a financial organization in the UK to help them implement that. They basically use HashiCorp Vault as a PKI, and that issues certificates on container launch time. So a container, every container has a sidecar container with Nginx in front that basically verifies a mutual TLS authentication. And the containers get given their certificates when they come up via HashiCorp Vault. It's quite a nice solution in that actually their certificates, they only sign them for 3 days. So after 3 days, a certificate is useless, and each of the containers roll every 24 hours or so. So they have this constantly moving fleet, which is a nice security product to that. The downside to this approach, and this is really why it's always a trade-off between convenience and security, is because of all the communication is now TLS within your VPC, you can't use HTTP load balancers anymore. You can't use layer 7 load balancers. You can't have HTTP-based checks on your load balancers. So all of a sudden, all of your load balancers are going to be TCP-only load balancers. And the only thing they're going to be able to do to health check a service is just look at the TCP port and say, is it open, is it not open? So you kind of dumb down the health checking capabilities. So that's something to be very aware of. It is very much a trade-off on convenience security there. So I wouldn't take that decision too lightly, but ultimately the way you choose to go, both are supported. It will depend on your risk and security requirements.
Let me suggest SSH and SSH tunneling, which is a safe bet and simplest bet in any case.
Yeah.
So you can install self-signed certificates in instances and communicate.
Yeah, and that's what this financial org we're doing. It just means that all of a sudden you can't use HTTP load balancers and health checks between. Same with SSH.
Why doesn't AWS allow installing certificates on the instances, only on load balancers?
Yeah. Yeah, so this is a feature request I've had a number of times. I don't have an amazing answer for you. I can't say, yeah, we're working on it, it's going to be there tomorrow. We've heard that feature request loud and clear. We have a lot of customers that want to do mutual TLS in their architectures. Generally, when we see people doing the same thing over and over and struggling with it, that's exactly the sort of time that AWS comes in and productionizes that. So I can't say any more here, but we've definitely heard that requirement loud and clear. Yes?
If you just encrypt the body of the HTTP, can you then use the load balancer because it puts on
The header information? Possibly, but then you're going to be doing that encryption, decryption within your application at the application layer. Yeah, possibly. Be interesting. Like if you play around with that and get that working, let me know and we can work on a blog post together or something. Yes. Yes.
Well, one question I have, in the examples that you were showing, the application itself that was running in the container was integrated with EC2 parameter store where some encrypted values were put in. I mean, of course, another alternative here would be KMS or something like that. But the question I have is, when you run something inside ECS, is there some kind of easy integration to, for example, just allow the container to grab the application secrets and export them into the container as environment variables, for example, because that would make it possible to, for example, not integrate the application itself directly with the parameter store or CMS, but instead just access them via some kind of standardized interface, which would be environment variables.
Yeah.
Is there some kind of easy way around that?
Not today that I've seen, but I think that's really good feedback, to be honest. At the
something like that is possible in Lambda, if I'm not wrong here.
Yeah, so with Lambda you have environment variables and you can choose to encrypt them with KMS. Yeah, it would be great to have some tighter integration here. Again, happy to take that feedback back to the team. If you can find me afterwards and we can write like a couple of sentences about your use case there, I'm sure it's pretty generic for everyone's, but we can take that back.
You would just have to use either parameters or maybe KMS or maybe use a third-party solution like Vault and integrate your application directly and fetch the application secrets from there.
Yeah.
But there is no way to have it automatically exported.
Correct. Yep.
Can you expose credentials from the parameter store in other ways then?
Yeah, so parameter store isn't limited to ECS at all. It's a separate service. It's just got a simple put and get API that you can integrate with Lambda. You can integrate it with ECS, etc. There's a lot of flexibility there. It's not tied to one particular methodology at the moment. But to that point, it would be nicer to have some better integration there. I understand that completely. Okay. Let's wrap it up. If anyone has any other questions for me, feel free to come find me. I'm doing another talk in 2 minutes' time on Kubernetes in here. But come find me over lunch, and I'm happy to dive into this stuff. Thank you.